Today I'm going to create a home security alarm system circuit on a breadboard, and I'll walk you through it step by step. First, you will need a BC547 transistor. Insert the transistor into the breadboard carefully, aligning the legs correctly. This transistor will act as a switch to control the alarm system based on the IR sensor's input. Next, take two jumper wires and insert them into the breadboard. One jumper wire should connect to the emitter pin of the transistor, providing a pathway for the negative side of the circuit. The second jumper wire will connect to the collector pin of the transistor, which is where we'll connect the output components, LED and buzzer. The next component you'll need is a buzzer. Insert the buzzer into the breadboard, ensuring that the negative pin of the buzzer connects to the jumper wire that leads from the collector of the transistor. This ensures that when the transistor switches on, it will activate the buzzer. Now insert an LED into the breadboard in parallel with the buzzer. This means connecting the LED's pins across the same points where the buzzer is connected. The LED will turn on when the buzzer does, acting as a visual indicator. Insert another jumper wire into the breadboard, connecting it to the positive pins of both the LED and the buzzer. This connection will provide power to both components. Next, insert another jumper wire to connect to the base pin of the transistor, which controls when the transistor turns on or off. You'll now need a 33 kilo-ohm resistor. Insert this resistor into the breadboard between the positive pin of the LED buzzer and the base of the transistor. This resistor limits the current to the base of the transistor, controlling how much current it needs to switch on. Then insert a 1 kilo-ohm resistor into the breadboard, connecting one side of the resistor to the base of the transistor. This resistor works with the IR receiver to form a voltage divider, which determines when the transistor will turn on. The last key component is the IR receiver. Insert it into the breadboard, connecting it between the 1 kilo-ohm resistor and the emitter of the transistor. This component detects infrared signals from an IR transmitter and controls the circuit's switching behavior. Now it's time to power the circuit. Connect the negative terminal of a 3.7-volt battery to the emitter of the transistor. Connect the positive terminal of the battery to the positive pin of the LED and buzzer, supplying power to the alarm system. When the circuit is powered, you'll notice that the buzzer and LED are turned on, signaling that the system is in an alert state. Next, take an IR transmitter and insert a coin battery between its two pins to power it. Bring this IR transmitter close to the IR receiver on the breadboard. You'll observe that when the transmitter signal reaches the receiver, the LED and buzzer turn off, simulating a door closed condition. This clever setup forms the basis of a simple home security system. You can fix the breadboard circuit on the frame of your door and attach the IR transmitter on the edge of the door itself. When the door is closed, the IR signal keeps the circuit off, no alarm. But when someone opens the door, the IR signal is cut, turning on the LED and buzzer to alert you.